Okay, we're going to go ahead and start our examples 9.4, and these are applications of logs. So we're starting to get into the reason that you use logs in a real life situation. Okay, and basically, in its most basic form, a log is used to find that exponent that's unknown. So if we don't know in the future how many years down the line it's going to meet these certain requirements, that's how a log can help us. Okay. Now, we're going to be dealing with finance, and then we're going to be dealing with population. And so I want to put two formulas up here, and I want to have you write those down. And those are ones we've dealt with before. We dealt with them when we did exponents. And those are these. The amount that you earn is your principal, and then 1 plus the rate divided by n. R is your rate. And what is n? Do you remember what n was? Good, good. The number of times that it's compounded. Very good. So this is talking about compounding. Raised to the nt. Okay, so that's what we're going to do when we're dealing with finance. And so then I'll put the next formula when we do with our population. All right, so here we go. Number 1. How many years will it take for $300 to grow to $1,500 if the invested money earns interest at 12% compounded annually? Okay, so what are these numbers here? What's 300 in relation to all my variables? What is 300? Principal, good. That is my principal. We want it to grow to 1,500, so what's that? That's our amount that we are achieving. That's our capital A. It's invested and it earns interest at 12%. So that's our rate, and we want to always do our rates as a decimal. And it's compounded annually. So what does that mean our n is? That would be it would be 12 if it was compounded monthly, but compounded annually is 1 time per year. So n is just 1. And then you just fill it into the formula. So here's how that looks. 1,500 equals 300, 1 plus 0.12 divided by 1 to the 1 times t, exactly, or x, whatever. This is your variable. See, so notice your variable is up in the exponent. That's what logs help you do, is to solve a problem when you have a variable up there at the exponent. Okay, so what do you think we should do first? Yeah, let's kind of simplify what we got in the parentheses here. And how much is that in the parentheses? 1.12, and I'm just going to put t here. Okay, now what? No, do not log it at this point because, and this is a very common mistake, only 1.12 is raised to the t power. 300 is not. Therefore, you have to get rid of the 300 first. So divide by the 300 first before you log it. When you log it, that's just when you have only the exponent left over there. Okay, so now what I have is 5 equals 1.12 to the t. And so we're saying, how many times am I going to have to multiply 1.12 by itself to equal 5? Well, we're not going to guess and check that. Now we know how to do it better, and now we can do what? Now we can log it. So we're going to log both sides. So I've got log 5 equals t log 1.12, and then what? Divide by log 1.12. So t is, whatever that amount is, 14.2. I don't know, how many decimal places was it? Yeah. What was it? 14.2 what? 015. Okay, yeah, let's just be consistent. We'll keep doing that. And these are years, because T is the number of time amount in years. So there we go. Okay, good. Let's do number 2. Yes, number 2 is still finance. How many years would it take for $4,000 to grow to $10,000 in an account that earns 8% interest compounded quarterly? Okay, so see if you can't fill those things in. It's just filling in a formula and solving. This would be my principal. This would be my amount I'm trying to achieve. This would be my interest rate. And what is n if it is compounded quarterly? 4. Okay, so plug that in. What did you do before you logged it? Yes, divide by 4,000. Okay, now I'm going to log it, and what's that going to bring down in front? Good. I'm going to log both sides. And so, well, you can do this in 2 steps. I got 4t log 1.02. Okay?
I divided.
And so you got a couple of things going on here, and you have to be careful, or else you're going to have a mistake in your calculator. Probably the safest way to do this would be, divide by 1 and then divide again. So probably the safest way would be go ahead and divide by log 1.02, divide by log 1.02, and so therefore I'm saying 4t equals, okay, now I got 5.0257. Did I do that wrong? 1.02, and then it's 46 something. Okay, so when I got that 5 point something, I had done it. I had divided by the wrong thing. Okay, so let me go ahead and do that real quick. There's the calculator. Okay, so we're saying it's log 2.5, close the parentheses, divided by log 1.02 equals, okay, good. Which is what you guys said, and I was all wrong, and you're saying yes. 46 point, what was the decimals? 2. Okay, now then divide by 4. Divide by 4, and so t is what? 5, 6, 7, something. Okay. All right. That's the safest way. I mean, otherwise, you would have to do this way. You would have to go log 2.5, close the parentheses. Hello. Log 2.5, close the parentheses, divided by, and you'd have to put that whole bottom thing in parentheses, divided by 4 times log 1.02. That's the way you could do that all in one step. And then that gives you that. Okay, so that is a way you could do that all in one step, or you could just do 2 steps like we just practiced. Okay, next. This is now population. Population growth is follows the growth and decay model. The formulas that we used for the growth and decay model was this. Okay, so take a look at those. Do you remember from our exponential functions what A represents? Remember how it's like the y-intercept? It's your starting amount. So it's your starting population amount. Okay, now, why do I have two different formulas up here? One would be if it was growing at a particular rate. What would this be with this E model? It's growing continuously. So, this first one, population of the world is growing continuously. So that's implying that I'm going to use the formula that has the E within it. At a rate of 2%, so that's going to be our rate. The current population is 8 billion people. So where do I put that? Where does that current population go? That's your A. So that's your starting amount. So, you know, you may want to make it, this is your starting amount. Okay, and how long will it take for the world to then have 14 billion people? Okay, so what are the applications of this? You know, we're talking natural resources being used up, all of those kinds of, you know, when do we need to have this many roads built by, or this many, you know, whatever resources figured out? When do we need to have another planet figured out that we can go to? Okay, so, you know, there are real world applications to this. When do we need to have a space center out there in space to put all these extra people? Because when will we have 14 billion people on the world, or on Earth? Okay, so we're going to fill this out. Y equals 8 billion. I'm just going to do this in billions, I guess. And then E to the rate, which is our 0.02t. Okay, and so I want to know when I'm going to have 14 billion, so I should replace, where do I put the 14? That's where I'm wanting it to equal it, so that's my 14. Okay, now what? Okay, good. So I'm dividing by 8. Now, the reason that I was able to just leave those as 8 and 14 is because those billions cancel out right there anyway. I could have put 8 billion and 14 billion, but they cancel out to be 1.75, whichever way you write that. Okay, now, how do I solve? Good, let's do natural log because we have an E involved. So our natural log of 1.75 equals 0.02t, natural log E. And what do you know about natural log E? It's 1. So to finish solving out for t, I'm just going to divide by 0.02. And t equals natural log 1.75 divided by 0.02, and I believe that I got 27.9 something. Is that what you're going to take it? 27.9809. Okay, so what does it say? How many years will it take for the world to have 14 billion people? If it's growing continuously at this rate, then we're talking, you know, almost 28 years. Okay, so this is a real world application of this. Then you go have a job on just all pure resource management. Okay, and that's what this one has to do with also. You know, you're talking about the black bears and you're having a food shortage situation. You know, what happens is you have a growth in a predator, and then the prey then the things that they eat start dying away because they're eating a whole bunch of them, and then if there's a huge food shortage, then the black bears start dying. And so you got this cycle of life going on with the food shortage and then a food overage and all that kind of stuff. Wildlife management team in one region of Alaska has determined that the black bear population is growing at a rate of 4.3% per year. The region currently has approximately 1,300 black bears. So what is this telling me? That's my what? That's my starting point. That's my A value, my starting. Okay? There will be a food shortage problem if the population reaches 5,000. So that's this over here, what it's equaling. I'm going to see when is that going to occur. And then since it says when is this food shortage problem going to occur, if this growth rate remains the same, it's also saying that the population is going to be happening continuously. So I'm talking an E model. What's my rate? 0.043. Okay, so solve that out and see what you come up with. Okay, so after solving all of that, you end up having natural log of 3.8462 divided by 0.043. Your natural log of E went to 1. And so then you end up with 31.327. I have 7.3 years. You might have been a little bit off on that because when I actually calculated mine, I didn't have any rounding at all. So mine might have been a thousandth off or something. Okay. That's it. That's all that we're going to do on this 9.4. We're not going to do the Richter scale problems or the earthquake problems. There is one of those on your lesson that you can omit. And so you are going to be able to omit problem number 3 on your assignment, lesson 9.4.
Why can I do this?